A simultaneous equation is when you've got two unknowns, so two letters where you're not really sure what they equal. And it's also when you've got two equations put together. So, for example, if you look at number 1, we've got 4x plus y equals 19 and x plus y equals 7. Now, the x and the y will be the same in both of those equations. So if I label the top equation equation 1 and the bottom one equation 2, let's pretend x is 1 in equation 1, then x would be 1 in equation 2. That's just an example, it's not actually 1. But to figure it out, what you need to do is we need to get rid of or eliminate either the x's or the y's. Now, in this situation, we're quite lucky because we've got a plus y on the top line and a plus y on the bottom line. So a good way to eliminate that is to think of it as a column subtraction. So I'm going to write a subtraction line sign there, and I'm going to write the equal sign underneath. Now we do this exactly the same as if it was just a simple column subtraction with numbers. Even though there's letters, there's equal signs, there's signs, it's all going on here, but just imagine it as simple as just a normal column subtraction with numbers. So let's start on the right hand side. So we've got 19 take away 7, which is 12. The equals, we'll just write that underneath, just like imagine it's like a decimal point. When you're doing subtraction of decimals, you keep it in that straight line. It's the same with the equals in this. And then the y, take away the y, makes 0. So that's nothing left. So we've eliminated that y, which is what we were aiming for. And now we've got 4x take away x, or subtract x, which leaves us with 3x. Now this looks a lot easier, and it looks just like a normal algebraic equation where we can just use simple inverse operations to find x. So we remember there's a mini multiplication sign between the 3 and the x, which means the inverse of that is divide. So we divide both sides by 3, which leaves us with x equals 4. Now that's brilliant, we've got the x, but we're not done there because we also need to find the value of y. So it's really important here, especially when you're doing exams, to write what you're doing next. So what you're doing next is you're going to substitute x equals 4 into one of the equations above. Now the easiest equation is number 2 because there's less x's there. So I'm going to write sub x equals 4 into equation 2. Now that's going to guarantee you a working mark, even if you make mistakes with the actual numbers and get the wrong answer. This alone is going to show the examiner or your teacher or whoever it is that you know what you're doing. So we're going to substitute x equals 4 into 2. So instead of writing x plus y equals 7, we're going to write 4 plus y equals 7. And then it's just the same as normal algebra where you do the inverse operation. So you're subtracting the 4 to leave the y by itself. So you're left with y equals 3. So now you've got x equals 4, y equals 3. If you'd like, you can substitute it. You can put these numbers into the above equations just to see if they work, just as a way of checking. Now number 2, on the right hand side, the blue simultaneous equation I've written there, it requires an extra step. You can't just subtract the bottom line from the top line, because if we do that, we've still got x's and y's on the bottom. So in this situation, I'm still going to label the top line 1 and the bottom one 2, but we need to do something to get either the x's or the y's to be in the same thing. So the easiest thing here is to get the y's being the same. So we want to get the y's being 2y. So in order to do that, the best thing to do is look at the equation 2, and we have to multiply the entire equation by 2. And that's going to give us our new equation. Our new equation for that would be 4x plus 2y equals 32. Because what I've done is I've done 2x times by 2, I've done y times by 2, and I've done 16 times by 2. Now, we're going to now label this new equation. I'm going to label it equation 3. So now we're going to get rid of equation 2. We don't need that anymore. That one's useless to us. So now we have equation 1. We're going to rewrite this, which is 5x plus 2y equals 37. All I'm doing is rewriting. And equation 3, which is 4x plus 2y equals 32. And now it's exactly the same as what we did in our first problem. So because we've got 2y on the top and 2y on the bottom, so you just treat it as column subtraction again. So we start on the right hand side. 37 take away 32 is 5. The equals sign, just keep them on top of each other. 2y subtract 2y means there's nothing left, so 0. And 5x take away 4x leaves you with 1x. So now we've got x equals 5. Brilliant. That's really good. Although we now need to find our y. So again, it's really important that we write what we're doing here. So I'm going to write. We're going to sorry about this. We're going to substitute x equals 5 into one of our earlier equations. And the easiest equation there, I'd say, is equation 2 again, because there's just less x's. So I'm going to write sub 5, x equals 5 into equation 2. So now we've got 2 times by 5 plus y equals 16. So that's the same as saying 10 plus y equals 16. And now we just subtract the 10 because we want to get that y by itself, which leaves us with y equals 6. So then we've now got x equals 5 and y equals 6. So a good thing to do here, if you want to, is to go back and check by putting x equals 5 and y equals 6 into one of your other equations, just to see if it works.